The table gives the millions of metric tons of carbon dioxide emissions from biomass energy combustion in the United States for selected years from 2010 projected to 2032. Part A says, find the equation of the regression line that gives the millions of metric tons of carbon dioxide emissions y as a function of x, the number of years after 2010. Now, this question specifies x as the number of years after 2010. So we can't just plug in the years as we see them. We have to translate them into years after 2010. So 2010 would be x is equal to 0 because 2010 is 0 years after 2010, or that's our starting point. 2012 is 2 years after 2010, so that would be x is equal to 2. 2014 would be 4, and so on. So we always need to be careful which year they specify as the starting point. So sometimes it will be 2010, sometimes it will be 2000, sometimes it will be 1900. Now I want to enter in the data and calculate the regression line. So press Stat, and then select Edit, and I'm going to enter in the x values into L1 and the y values into L2. And then quit out. Then go back into the Stat menu, go over to Calc, and down to Linear Regression. So then it appears on the home screen on my calculator, and then I press Enter. Again, your calculator may go to a different screen where you have to go down and press Calculate one more time. But then this screen should show up. So this is all of the information that we need. So the equation is y is equal to 18.962x plus 321.509. The correlation coefficient r is 0.997, and the coefficient of determination r squared is 0.995. Now let's look at the graph. I'm going to go to the y equals button and then type in my equation into y1. And then press Zoom and go down to Zoom Stat. And this is what our graph looks like. So there's the graph. For part C, 0.997 is extremely close to 1. So this is almost perfect positive correlation. And the model fits the data extremely well. So the line almost goes through every single dot, and that's why the R value is so close to 1. Now the coefficient of determination is 0.995, which means 99.5% of the variation in CO2 emissions can be explained by the relationship between the year and CO2 emissions. And the other 0.5% of the variation is unexplained.